Hello and welcome. Today I am going to show a very simple analysis step, namely that is cropping a Nifti file that might be too large to process, or maybe you just want to focus on a single region in that file, and how to achieve it and how to process with that. So this video is made for my colleague and the collaborator Emily Allen, who is a research assistant professor at University of Minnesota, Department of Psychology, Auditory Perception and Cognition Laboratory. We are running a project together with Emily, which is looking at the details of the auditory cortex in living humans. And therefore we recorded some data, and now we are moving to the analysis stage. So this is a video to show Emily one of the important steps in our analysis. So first of all, in this analysis, we are trying to repeat an analysis that I have done in the past on a new data set that Emily acquired. And our target paper to repeat the analysis is my 2022 neuroimage paper, where we have acquired T2 star images at 0.35 millimeter isotropic resolution in humans. So I'm going to use the data set and the scripts that were published together with this paper to demonstrate the step today. If we move to figure 1 just briefly, you can see that we have only acquired roughly 1/3 or 1/4 of the human brain, and we acquired the data in such a way that we get the Heschel's gyrus, where the primary auditory cortex is located at, mainly. So this is a partial brain coverage data. And the analysis that we would like to repeat together with Emily in this project is basically segmenting very carefully the auditory cortex region and looking at the laminar patterns inside the anatomical data there. And already in my figure 2 here, you can see that we are only focusing at the auditory and the visual cortices, and we don't have the frontal lobe. And this is done for multiple reasons, because we just wanted to analyze these two different regions of interest. And because this was a very high resolution data that is at 0.35 millimeter isotropic, and analyzing this data at double resolution, which is upsampled twice, which makes it nominally 0.175 millimeter isotropic, can be a bit heavy for like laptops, for personal laptops, and maybe a bit slightly older computers. Therefore, it is more beneficial if you just crop the regions that you don't care in this data set. And you can see that here, I don't even have the frontal cortex reported in the figures. Okay, so we have many more analyses in this data set, but what we should focus on first is the section 2.7, that is the data and code availability. You can see that here we state that the data and the code is available. So let's see our Open Science Framework repository. Okay, then navigate to the folder. You can see that there is a derived folder and the source folder. I will go to source for this video. And here I'm just going to download one of the subjects. Let's download subject 4. Okay, the subject has been downloaded. Let's unzip it. And let's see what's inside. So you can see that there is the session for T1 and session for T2 star. Now we are interested in the T2 star session, where we have the multi-echo GRE acquisition. And here you can see our 4 runs before pre-processing. Let's quickly have a look at one of them. And here it is. You can see that this is an anatomical image with multiple echoes. You can see that I can switch between the T, the time dimension, and I can see different echoes of the same anatomical image. So this is the type of data that we would like to analyze together with Emily as well right now. Okay, so for computational efficiency in the future, the first step that I do is cropping this data. And just to be complete, I would like to show you that when we click on the same section, the second link that leads us to the analysis scripts, here a GitHub link, you can see that here is the repository for holding the analysis scripts that I have used in this dataset, in that dataset. So when I click on scripts and I go to multi-echo GRE section of it, these are all referenced in the paper. So exact references are in the paper. I'm just now moving fast. You can see that there are a number of steps that have been performed. And the first one is called crop. Okay, so we are interested in this file. Let's also download it. I'm just keeping things simple for now. We have downloaded it. So just for simplicity, I'm going to put the files that I'm going to use in the same folder. Let's take one here and put it down as well. Okay, so let's have a look at this cropping script for a second. When we look at that script, you can see that there are names of the Nifti files. These are 4 different runs. And I have now moved all the four different runs in our folder here. And you can see that there are different parameters for different subjects. So now, just for this video, let's call it demo or Emily. So you can see that it takes 4 complete paths. This is a Python script. It takes 4 complete paths. You need to give it a output directory and a couple of parameters here. And it basically wraps around the fslroi program, which requires that you need to install fslroi or FSL in general in your computer to access to this program. And it's a Python script. Basically, it takes some inputs, it wraps around fslroi and does the cropping operation, which basically reduces the size of your image. Okay, so let's proceed. I can call itk snap, and now in my partial brain coverage data, what I need to do is to determine the region that I am most interested in. For instance, I already know that I am interested in the Heschel's gyrus, and I am rather familiar with this gyrus, so it's easy to locate. So it is here, and I would like to get all of it. So I'm looking up and down a bit, following the gyrus here. I can also have a look here and see how the gyrus is progressing. You can see that it is there, progressing and going more and more anterior. So maybe maximum here, most anterior. So at this moment, what I would like to do, maybe a little bit further, is to find which axis this is. So you can see that I am moving around a bit, and I see that the fastest changing dimension is the Y dimension, 397 there, and you can see that it is changing really fast. And maximum of that value is 575. So all this part that has the frontal cortex, we actually don't care. We are not going to analyze anything there. So I can just cut this image from the frontal part and focus on the region that I'm interested in. So that's why I'm going to determine a range in the y-axis that is most relevant for me. Okay, so let's take it as, let's say for easy, 370 for y. So let's note it down. X, Y, Z. And from where until the 370? Is it from 0? Well, there is some region that does not have any brain. So I can maybe cut, let's say 20 slices there as well. So okay, my Y range is that 20 to 370. So I can do the same for the left-right direction. You see it's the fastest changing dimension is the X dimension when I go left to right, see? And most of the coverage here does not include the brain. We had a square field of view for another reason here. Okay, so let's say I would like to start from 90 and I would like to go up until, let's say 490 in X. Okay, I note it down. 90 to 490. And Z, so we have a limited coverage in Z, but maybe this uppermost and lowermost slices, they have some wrapping artifact that is expected. Maybe we don't want to have those slices included in our image to begin with. So let's say that we can get rid of some of these. Let's say from 104 to 98. Let's say 5 of them. 99 is the maximum. And the minimum is, let's have a look at from the bottom side. Again, maybe we just cut 5 of them. Let's say 5 to 99. I mean, this can also be 10 to 95. Let's be more conservative for now, just demonstration. Okay. Let's see. 10 looks pretty good. 95 looks pretty good. No more artifact visible. Fine. So now here, the other thing I would like to do is to just compute the size, because that's how I like parameterize it. That's what fslroi like. So 90 to 900 and so 90 to 490 is 400 units. This is 350 units. And this is 85 units. So let's remember these numbers. So 90, 20, 10. And let's enter here. 90, 20, 10. And the size is 400, 350, 85. 400, 350, and 85. You can see that this is commented what these values mean. It's the XYZ minimum and XYZ size. That's why we looked at the size of the range that we are dictating here. Okay, now I have saved this file. Let's set it up to paths as well. So one easy way to do it is that you just go to your file browser, select all the paths, and do Command Option C. When you do like this, it is going to just copy all the paths together as an absolute path, and you can quickly enter them like so. Okay, let's remove the old paths, and let's give it an output directory. Let's say the same directory, yes. And let's make it, yeah, 01 crop, the output folder's name. Let's save it. And now let's run this Python file. So how can we run this Python file? What we need to do is to open the terminal. Here I already initiated it. And change directory to the folder where my Python script is residing in. I can just drag and drop. You can see in Mac. So now I am in the same folder, I am sure. ls gives you what's inside the folder. But basically, I need to run 01 crop. So before I run it, I need to make sure that fslroi is installed and available. So let's say fslroi. Oh, I don't have it. Okay, I just realized that I didn't have FSL installed in this computer, so I quickly installed it. Now, getting back to the video. Now, let's check whether I have FSL installed or not, and whether I have access to the fslroi function. Simply type fslroi, and it returns the help menu, basically. So it is there, which means that my Python wrapper should work correctly. Let's execute the Python wrapper. Okay, so you can see that it already created a folder and should be putting the new data there. You can see that in comparison to the input data, now it has a suffix called _crop. And as the outputs are coming, we can start inspecting some of them. Let's have a look at the first one. And you can see that this data is now cropped. This is not a necessary step. I used to do this because I had a much weaker computer when I was writing that paper in 2021. So if you have access to a strong computer or a newer computer with a more RAM and so forth, maybe you don't need to do it, but Emily just wanted to see this step and how I perform it. So here I have performed it. We can also overlay the old one on top. fslroi has a advantage compared to cropping the data dimension yourself in Python, for instance, because it automatically keeps the image header correct so that it can even be overlaid with the old data, as you can see here. And all the echoes are there, of course. Okay, that's it for today. Good luck with your analysis, Emily, and have a nice day.